Hello everyone. Welcome to the next lecture on the IIT Jam and Mathematics solution. Today I will explain you how you can solve the problems related to the line integral. I will explain you always with the help of the shortcut tricks. Myself Dr. Harish Garg. You can follow my YouTube channel where you can find the playlist of the IIT Jam solution. And in this playlist you can see the various lecture related to the IIT Jam Mathematics and statistics available with the help of the shortcut tricks. Also you can find the playlist of the CSR net as well as the gate mathematics for finding the various topics solution in a very easier manner. I hope you can subscribe my YouTube channel so that when I upload my next video you will get the notification. Now dear students, whenever there is a question related to the line integral, that is whenever the symbol is appearing here, always come in your mind is either you can apply the Green theorem or the Stokes theorem, always. Now the question arises is under what case you can apply the Green theorem and the Stokes theorem. Whenever your dr is your either in the 2 dimension, this is my case of the 2D. Similarly for the case of the 3D I can write as a dz k cap. Whenever the case of the 2 dimension problem you can apply the Green theorem. Whenever the case of the 3 dimension you can apply the Stokes theorem. But provided the Green theorem is applicable, provided the first case, C, that is a curve. The curve must be my closed curve. Fine. And the second part is whatever the F, if I called as F is my P I cap plus Q J cap. This is the vector field. Then the P, Q and its derivative. Fine. P, Q and its derivative, if they are my continuous, then only you can apply the Green theorem. Fine. Both the condition must be satisfied. The curve must be closed and P, Q and its derivatives are continuous, then only you can apply the Green theorem. I again repeat, अगर कर्व जिसके साथ आपको इंटीग्रेट करना है अगर वो क्लोज नहीं है और इनका कोई भी डेरिवेटिव कंटिन्यूस नहीं है तो आप ग्रीन थ्योरम अप्लाई नहीं कर सकते. सिर्फ एक ही केस में ग्रीन थ्योरम एप्लीकेबल होगी अगर वो कर्व भी क्लोज है और इसके डेरिवेटिव्स और फंक्शन कंटिन्यूस है. Similarly, if it is of the 3 dimension, then you can apply the Stokes theorems, while for the 2 dimension you can apply the Green theorem. The rule is very simple. You can take the partial derivative of q with respect to x and the p with respect to y. Now look at that. A very simple approach. First of all, always draw the region. This is R. Check whether this is closed or not. X is 0. X is 0. X is 1 minus y square. This is a graph of the x is 1 minus y square. Why? Because you can see x is 1 minus y square. That implies y square is 1 minus x. It's a parabola. Y is equal to 1. This is the point is 1 comma 0 or minus 1 comma 0. And this is the point of here. Find which one is the curve. This is my curve. And clearly say this curve is my closed curve. Fine. This is my q. This is my p. Both are polynomials and they are continuous as well as their derivatives also continuous. So then you can apply the Green's theorem. Fine. So what is the Green theorem is? Double integration, partial derivative of this coefficient of the dy with respect to x minus partial derivative with respect to y into dx dy. You may consider as a dy dx as well. Fine. So that will be double integration of 1 into dx dy. Now can you find the integration of this? Clearly say this is my symmetrics. So I can say double the area of this portion. So what are the limits? Along the x-axis I can take the strip 0, 1 minus y square and the y-axis will be my 0 to 1. Now can you integrate them? It is 1 minus y square into dy. I think the rest of the part you can do it by own because that's a simple plus minus integration that you can do it in a very simple manner. So 1 minus 1 over 3 minus 0, which is 4 by 3 is the right answer. You can get your answer in a very couple of seconds provided you have to check the two conditions, closeness and their coefficients are closed, continuous and their derivatives also continuous. Look at the second question. R is a planar region bounded by the curve x0, y0 and the circle in the first quadrant. Fine. So this is my curve. and clearly say this is my closed. Clear? Also you can see these are my polynomials, so they are continuous, their derivative is also continuous. Yes, you can apply the Green's theorem. I can say it's a double integration, partial derivative with respect to x minus partial derivative with respect to y. So partial derivative with respect to y is minus x minus minus plus x dx into dy. So which will be 3 times x dx into dy. You may take as the horizontal step and the vertical step. Otherwise, whenever there is a circle, you can always convert into the polar coordinates. Fine. So that your integration will be very easy. So I can change into the polar integration. So it's a r cos theta r dr, because dx into dy is my this. So what are the limits? Clearly say it's a radius. What is the radius? Is my 2. Angle in the first quadrant is 0 to pi by 2. So now I can take the integration. Firstly, with respect to r, it's r square r cube divided by 3. So that will be 8 over 3 into cos theta. Fine. So that will be 8 into sine from 0 to pi by 2. So 8 is my right answer. You can see that within the 2 or 3 line you will get your answers. Dear student, don't forget to subscribe my YouTube channel. Okay, now clearly say this is my continuous, this is my continuous, because they are the polynomials, so derivative is also continuous. Now check whether the region is closed or not. C is the boundary triangle by x0, x1. So clearly say this is my closed. So yes, the Green theorem is applicable. So now how you can apply the Green theorem? Double integration, partial derivative of this j, that is a dy, with respect to x, it is my minus of 6y. This is with respect to y, so it is a minus minus plus 8 into dx dy. Fine. Now that's over. You can solve this. It's a minus of 6 double integration dx into dy plus 8 is outside, double integration of dx into dy. Now can you take the limits? Firstly, I can take the limit with respect to y. Fine. So I can write this instead of, this is dy into dx. So in case of the y, I can take the vertical step. This is my 0. This is 1 minus x. This is 0 to 1. What is this case? This is nothing but the area. Fine. And how you can find the area of this region? It's a triangle, half base into height. And for this case, how you can integrate them? It's a y square by 2. It's a 1 minus x square divided by 2. How you can integrate them? It will be my 3. So minus of 3. What is the integration of this? 1 minus x cube divided by derivative of this is also minus 3 from 0 to 1 plus 4. If you substitute 1, it's a 0. Minus 3 cancel. 1 will be 0. So it's a minus of 1 plus 4. Answer is my 3 is the correct answer. Always get your answer in a 2 or maximum 3 lines. If you draw the curve, check whether it's a closed and check whether the continuous condition satisfied. Okay, look at this one. Firstly, you can draw the graph. Center is 1, 0. Radius is 1. So this is my circle. Fine. And the curve, this is my region. So clearly say this is my closed. Fine. These are my polynomials. This is my polynomial. So polynomials are my continuous. Derivatives are also continuous. So yes, you can apply the Green theorem. Double integration. Derivative with respect to x, 4x cube, minus derivative with respect to y. So minus minus plus 4xy square into dx dy. Fine. So 4 I can take as a common. Double integration of the x square plus y square dx into dy. Now how you can integrate them? Either you can take as a curve, otherwise I can change, it's a circle, I can change in the polar coordinates. So x minus 1 will be my r cos theta and y is my r sin theta. So I can substitute the value here. This is the double integration. X is my 1 plus r cos, fine, x square plus y square. So x is my 1 plus r. So it is a 1 plus r square plus 2r cos theta. Dx into dy is r dr into d theta. What are the limits? Radius is my 0 to 1 and it's a complete circle. It's a 0 to 2 pi. Now what is the integration of this? Firstly, I can multiply them. It's a 1. I can also multiply by r. It's a r. It's a r cube plus 2r square cos theta. I can multiply by r cos theta. It's a r square cos theta. R cube into r4 plus r 2r square into r is a 2r cube cos square theta. Dr into d theta. Fine. Now since the limits are my constant, you can integrate directly. So it will be, or firstly you can integrate with respect to r. It's a r square by 2. So that is a 1 over 2. It's a 1 over 4. It is my 2 over 3 cos theta plus 1 over 3 cos theta. It is cos theta divided by 5 and it is 2 over 4 cos square theta. Fine. Now what is the integration? 0 to 2 pi. This value will be 0. Why? Because you can clearly say what is the integration of the cos is sine. When you take the limit from 0 to 2 pi, it is 0. This value is also 0. This value is also 0. And this value, what is the integration of the cos square? By using the orthogonal property. You must remember the orthogonal property. So it will be whatever this angle divided by 2. So that is my pi. So I can substitute the answer. Let me clear this screen. So answer will be 4. Fine. It is 1 over 2 plus 1 over 4. It's a 3 over 4. Integration from 0 to 2 pi is 2 pi. 0, 0, 0. This is plus 2 over 4 into pi. Fine. So the answer is 4 will be cancelled out. So 6 pi plus 2 pi. 8 pi is my correct answer of this problem. Look at the next one. F is there, the point at which the gradient of the function is 0. Del of f is my 0. Fine. So it's a very simple how you can find the gradient. Del f upon del x is 0. Del f upon del y is 0. Del f upon del z is 0. So that implies del f upon del x is 3x square minus 3yz is 0. Similarly for 3y square minus 3xz is 0. 3z square minus 3xy is 0. Now once you will try to solve this problem, you will get the xyz, but there is no need to do like this manner. What is the shortcut tricks? As I already told you in my previous lecture of the maxima and minima, clearly say this function is symmetric. Fine. Why it is a symmetric? Because if you replace x to be the y to be the z and z to be the x, the function remain the same. So once the function is symmetric, the gradient is 0 at the point x, x and x. Both are my same point. So clearly say they are not same. They are not same. They are not same. The only left behind is B is my correct answer. Otherwise, you can try to solve the problem. Again, you will get the answer as minus 1, minus 1, minus 1. But there is no need because the function is symmetric. So you will get the right answer in a couple of seconds. For more detail, I recommended you must watch about my lecture of the maxima and minima. Let me check. Yes, you can watch my this lecture of the IIT JAM and GATE maxima and minima. You will get the answer within a 15 second and you will see what is the beautiful shortcut tricks I explained you. Okay, look at this another one. First of all, you can draw the curve. It is an ellipse. Fine. So this is my curve. It is my closed curve. Fine. These are my continuous. Derivatives are also continuous. Then you can find the is a closed and continuous. Yes, you can apply the Green's theorem. So what is the Green theorem is? Double integration, partial derivative of y, because this is a j means dy. So partial derivative of this with respect to x minus partial derivative with respect to y plus 1 dx dy. So that will be twice is outside partial double integration of this. What is the meaning of this part is? This is the area of the curve and this is my ellipse, and we all know what is the area of the ellipse, pi into AB. So what is the right answer of this? Pi. What is the A? A square is my 16, A is my 4, B is my 3. So that is my 24 into pi. You can round off them. 24 into 3.14. You can multiply them and get the right answer of this problem. Okay, look at this another one. A is my I, J, K. R is given to which of the following statement is my false? Which of the following statement is my false? Okay, first of all, it is for all x, y, z. So let's say if I choose x is, y is, z, all are my 0 because this is a part of the R. Fine. Then your R will be 0. Fine. If R is 0, then the gradient of this value is also 0, but A is my non-zero. The left hand side is 0, but which is not equal to A. So that is false statement. Is it a true? No. 0 is 0. It may be 0, which is A. So which is not possible, which is not true, which is again not true. Fine. This is my 0. This is my 0. So gradient dot product of this is 0. This is also 0. So that's fine. Now for the other case, I can simply choose x is my 1, y is 0, z is 0. Your R will be I cap. Fine. Then what is the A cross R? A cross R will be 0. No. What is the A cross R? We will see. Firstly, I can find this A dot R. What is A dot R is 1. Then A dot R of R. So x is 1, R is I, so it is I cap. If you take the dot product with respect to I cap, this is my 1. So the left hand side is my 1. What is the A dot R? 1 into 4, which is not true. Fine. Now if you take A cross R, this is the gradient. This is A cross R. A is my 1, 1, 1, 1, 0, 0. So that will be I will be 0. J will be my minus of the K cap. Minus of J cap. And K will be my minus of K. Minus minus plus. So J minus K. If you take that dot product, it is 1 minus 1, which is a 0, which is my true statement. So the right answer is, which of the following statement is false? A, C, D are the correct answers. Let's see the boundary of the square with the vertices 0, 0, 1, 0, 1, 1, 1, 0, 1. Is it a closed? Yes, this is closed. Fine. Also, you can see these are my P, this is my Q, which are my continuous and which are polynomials. So definitely continuous and derivative is also continuous. I can apply the Green theorem. Derivative with respect to x minus derivative with respect to y. 2x square y over the curve dx dy. Now it's not a polar curve, it's not a circle. So what is the limit? 1, 1. So it's a 0 to 1, 0 to 1. So firstly with respect to x, I can integrate with respect to x. It's a x square. It is my 2 over 3 x cube of y from 0 to 1. It will be 1 minus 2 over 3 into y. Now you can integrate with respect to y. It is y square over 3 from 0 to 1. So the answer is 2 divided by 3 is my right answer of this problem. Fine. Okay, look at this another one. This is a gate examination paper. C1 is the boundary of the region x0, 1, y0, 1. This is my C1. Clearly say this is my closed curve. C2 is the boundary of the region -1 to 0 and -1 to 0. Again, you can see this is my closed curve. Again, these are my polynomials. Every polynomial is a continuous. Their derivative is also continuous. Then you can find the value of the alpha 1 by using the Green theorem. Double integration of partial derivative with respect to x minus partial derivative with respect to y, 2xy dx dy. So that will be twice is outside. It is my area under the curve. So can you find the area of this region? It's a square with the region 0, 1. So the length, so the right answer of the alpha 1 is my 2. A option cancel, B option cancel. Now similarly you can find the value of the alpha 2. This is double integration of dx into dy. So what is the area of this region? Length. So that is again 2. So C also cancel. D is my right answer of this problem. It's a very simple approach. You can see within a couple of seconds you can get your answers. If you really want, I can upload more videos or I can continue them. You have to like and subscribe my YouTube channel. Put a comment on the video so that I can understand that you like the videos and support my efforts. Again, you can see this is a line integral. Fine. So what is the reason is? It's a positive oriented, it's a rectangular region R. Fine. So it's definitely a closed curve, rectangular region. And these are my entire functions. So what is the Green theorem? What is the Green theorem is? Double integration partial derivative of this with respect to x. This is del square minus del square u upon del x square minus partial derivative of with respect to y. Fine. Dx into dy. I can take a minus is a common, which is del square u upon del x square plus del square u upon del y square. Now can you get the answer of this? What is given to you is an entire function. So u and v will satisfy my harmonic function, and once this is my harmonic function, the value of this will be my 0. So the answer is 0 is the correct answer of this problem. Okay, look at this another one. So firstly you have to check. Again you can see this is a continuous reason. You can check it. Y is equal to 1 plus x square. This is y is equal to 1 plus x square. Fine. Y is equal to 2. This is my y is equal to 2. And the point is my x, y is equal to 2. X will be my 1. And this is my minus 1 comma 2. And x is equal to half. Fine. Which one is a common reason? Which is bound enclosed by the line curve and it is positively oriented. Positive oriented means they are moving in the anti-clockwise direction. So they are moving in this side. So the curve is has, this is my positive curve. And it's a closed curve. Fine. And these are my continuous. You can find the double integration. Partial derivative with respect to x, e raised to power y over x plus 1. Partial derivative with respect to y, e raised to power x y of this case. Fine. So now you can see this will be cancelled. That is my area under the curve. But this, since this is the curve, you can take the limit dx dy. So firstly x, what is the value of the x at this is half. Value of the x at this point you have to taken by root. So instead of that, I can taken as a y x. The value of the y at this point is 1 plus x square. Value of the y at this point is 2. Value of the x at this point is half. Value of the x at this point is 1. Now can you integrate them? So it's a y. So that will be y 1 minus x square. Now you can integrate them. It is x cube by 3 from 1 2 half. So what is the answer is 1 minus 1 over 3 minus 1 over 2 1 over 24. So 2 over 3, it is 11 over 24. So 16 minus 11 over 24. B is my right answer of this problem. You have to draw positive oriented, that means it's an anti-clockwise direction. Okay, look at this another one. Curve x0, y0, circle lies in the first quadrant. Only this portion. Clearly say this is my closed curve. Also exponential is a continuous, derivative is continuous, polynomial is continuous, derivative continuous. Yes, you can apply the Green's theorem. Double integration, partial derivative with respect to x 0, partial derivative with respect to y 2y into dx dy. So that will be minus 2 outside, y dx dy. Again you can see it's anti-clockwise. Fine. Now because it's a circle, I can change into the polar coordinates. So it is x sine theta r dr. Radius is my 1. So r is my 0 to 1. In the first quadrant, it's a 0 to pi by 2. So minus r, integration of the r square is r cube over 3, and sine will be my minus cos theta. Fine. Now that you can substitute the limit minus minus plus 2 over 3. Value of the r is 1 minus 0. Value of the cos pi by 2 is 0, and cos, and so final answer is minus 2 by 3 is the correct answer of this problem. Look at this another curve. Let's see the smooth curve from some point. This is the point of the minus 1 to the 1 1 1. So clearly say this is my not closed. Fine. So once it is not a closed, so can you apply the Green theorem? Definitely not. Fine. Now once it is not applying the Green theorem, very simple. That means you have to function of phi. You have to function of phi so that this component will, you can written phi is my gradient of f. How you can find that? That's a very simple. Always remember, whenever it is not a closed curve, take the pair of the x. This is the 2xy. That's xy. Fine. Any other pair xy? This is the xy plus x square dy. Fine. This is my xz plus z square dx, and this is xz. 2xz of, fine. What is the remaining is z into dy. Fine. This is the integration of it. Now clearly say I can write the first part is x square of y, because if you take the derivative 2xy into dx and f, can you write the derivative of this? It is x of z square, and for this case you can write the derivative is zy. Is it okay? Fine. Now it's an integration, so derivative will be cancelled. Z square plus xz square plus of yz. This is my phi. Now once it's the area under the curve, or you can say the line integral. Line integral we also know as the work done. Fine. And once you can find the phi, so the answer is phi of from work done minus phi of minus 1 0 1. So now you can substitute the answer 1 1 minus 1. This answer is my 1. This is my 1. Y into z is a minus 1. Y is equal to 0. So this component 0, this component 0. It is my minus 1. So the right answer is 2 is my correct answer of the problem. Okay, look at this another one. Let's see. Okay, it's a polynomial, it's a polynomial, it's a polynomial. Can you apply the Green theorem? No. Why? Because it's a 3 dimension. So you have to apply the Stokes theorem. What is the Stokes theorem is? You have to find the curl of the function f and then unit vector. So firstly I can find the curl of the f. I, j, k. Partial derivative with respect to x, with respect to y and z. So it is my minus y, 2xy, z cube. So firstly with respect to I, 0, 0, 0, 0. And then it is with respect to x, 2y plus 1 of k cap. So your curl is my 2y plus 1 k cap. Then your n cap will be my k cap. So your answer is double integration 2y plus 1. Once n cap is my k cap, then your ds will be dx dy. So it is a x. Fine. Now you can see you have to take the absolute value. Now you can see it's a polar curve. So how you can write in the polar coordinates? Is a 2r sine theta plus 1 r dr d theta. So you can see this is the answer. Limits radius is 1 on the xy plane, angle is pi by 2. So this answer is cancelled out because there is a missing of the r. Now look at this b and d option. This is single integration. That means you have to solve this part. So how you can solve this? With respect to r, the first term is r. So integration is r square over 2 plus r square is r cube over 3 sine theta from 0 to 1. Now you can see it is my half plus 2 sine theta divided by 3 over the integration 0 to 2 pi. So that is the right answer. This option is cancelled out. Okay, look at this another one. Is a P to Q. Again you can see this is my not closed. So then Stokes theorem as well as the Green theorem is not applicable. Then your target is to find the phi. So clearly says how you can find the phi. There are the two methods. You can find the exact function mx. Fine. How you can find the exact differential equation? If you can check partial derivative of m with respect to y, partial derivative of n with respect to x, clearly say they satisfied, then its solution will be integration of the m into dx keeping y constant plus integration of the n not containing x of dy, which is c. Fine. This is the way you can solve this, but I will tell you simply. You can see e raised power x cos x dx. So I can write this function is e raised to power x cos y. You can see if you open the derivative, it's a e raised power x cos y dx, e raised power x minus sin y dy. So that means your phi is e raised to power x cos y. Then your target is to find the value of the phi from P to Q. So from Q of this case. Fine, from P to Q. What is the value of the 4 and pi by cos pi by 2 is 0. E of 0 is 1, cos 1. So the right answer is 1 is my correct answer. Now again from the straight line 0, 1 to the pi by 2, 0. Again you can see this is not a closed curve. If it is not closed, then you can't never apply the Green theorem, never apply the Stokes theorem. So can you write a function phi? You can see, first of all, it's a x, it's a 2D, sin x, cos x. So I can take y as a constant of, you can see, if you take the derivative of this, if you take the derivative, what will happen? It's a y plus 1 e raised to power y cos x dx plus derivative with respect to y, it will be y plus 1 e raised to power y plus y into 1 into e raised to power y of sine x dy. You can see it's a y plus 2. Otherwise, you can keep integration of the m, keeping y constant, plus terms in the n not containing x. There is no terms, which is c. So you can see what is the integration of the m, keeping y constant, y plus 1 e raised to power y. Integration of the cos is sine of x. So that c is called as the phi. So this implies your phi is y plus 1 e raised to power y sine x. Now your target is to find the point from A to B. So your answer is phi of B minus phi of. So what is the answer of this? Y is equal to 0. So it's a e raised to power 0 1 1 sine pi by 2 is 1. X is 0. When x is 0, sine 0 is 0. So the answer is 1. Dear student, believe me, this is one of the easiest topic. Follow this lecture very carefully. And please like, comment and subscribe my YouTube channel to support my effort. If you really want, I can upload the more video. You have to like, subscribe and comment on the video. If I get more likes and more comments, definitely I will upload the next video very soon. Okay, consider the vector field F where beta is any real number. R is my, small r is my magnitude, absolute value of the line integral over the circle. So clearly say this is a circle which is my closed, and P and Q, X and Y are polynomials, so they are continuous. So therefore you can apply the Green theorem. So what is the Green theorem is? Double integration, partial derivative of y with respect to x 0 minus of 1. Fine. Sorry, this is not, you have to differentiate. Sorry, what is your P? P is my r raised to power beta of y. Q is my r raised to power minus r. Yes. Now you can see this is a polynomial. Fine. So it is a continuous, and so you can find this derivative with respect to x. So derivative with respect to x is r raised to power beta. I can use the product rule. Then minus beta times r into del r by del x. What is the r? R is the magnitude of this. So r will be my x square plus y square. So this will be my x over r. Minus partial derivative with respect to y. What is the partial derivative with respect to y? It's r raised to power beta plus into x also. Product rule. Y beta times beta minus 1 del r by del x. It's r over 1. Fine. Dx dy. Now you can simplify this. Minus r raised to power beta minus r raised to power beta. Fine. It is a x square. I can take this minus beta r raised to power beta common. It is x square over r square plus y square over r square. Fine. So what is the value of this? This value will be my 1. So your integration becomes double integration minus 2r raised to power beta minus beta into r raised to power beta dx dy. I can take a minus twice 2 plus beta is outside, double integration r raised to power beta dx into dy. I can substitute the value of r like this. Otherwise, because it's a circle, I can change into the polar coordinate. If I change into the polar coordinate, this value will be minus, this is my r raised to power beta, this is r dr into d theta. Now you can integrate them with respect to r. Limits are my 0 to a and 0 to 2 pi. So minus 2 plus beta, it's r raised to power beta plus 1. So if you integrate them, it is beta plus 1, that means beta plus 2 over beta plus 2. And after the 2 pi, it is my this case. Fine, that's the integration. Now what is given to you? If the absolute value of this is given to be 2 pi, this is given to you. So then what is the answer? This will be cancelled. Beta plus 1 will be cancelled. That will be a raised to power beta plus 2 is 1. That will happen only when beta will be minus 2. So the right answer of this problem is minus 2 is my correct answer of this problem. Okay, if F is the vector field, xi cap, yj cap on the open connected set, which of the following statement is true? Divergence of the F. Can you find the divergence? 1 plus 1, 2, which is non-zero. The line integral of the F is independent. Yes or no? How you can check that? Line integral is independent. So independent means if you prove that the curl of the F is 0, then it means they are independent. Or if you prove that your F will form the exact equation, like I can write this F dot dr. What is the F dot dr? X into dy, sorry, x into dx, x into dx plus y into dy. I can write this function is half of. Is it fine? Fine. So that means you can say x square plus y square over 2 is the, which is called as say phi. Fine. So that means this is the exact. So therefore, if it is exact, the curl will be 0. Otherwise, you can find the curl. There is no issue. You can find the curl del x, del y, del z. So it is a x, y, 0. So clearly say first part is 0 minus 0. With respect to j, 0, 0, and which is 0. So once the curl f is 0, that means it is independent. And once the curl of the f is 0, what is the meaning of that? I can write a function f as the gradient of phi. And the line integral of the f is 0 because the curl is 0, so the line integral is also 0 on the smooth curve S. Okay, look at this another one. Again, it's a line integral. The path from the 0, 0 to 1, 1. Clearly say it is not a closed curve. Once it is not a closed curve, you can never apply the Green theorem. Fine. So your target is to find the phi. So what is your f dot dr? Basically, it is root x into dx plus x plus y cube of dy. Fine. Now can you say, if you look about this part is m dx plus n dy, is it exact? What is the partial derivative of m with respect to y? This is the condition for the exactness. Fine. Otherwise you can find the curl. What is the partial derivative of m with respect to y? 0, n with respect to x 1, which is not exact. Fine. Once it is not exact, how you can find the phi? So it is not possible. So I can substitute these limits. X into 2t of dt plus x t square x y cube 9 dy. dy is my 3 t square of dt, and the limits of the t is my 0 to 1. Fine. Because clearly say we have seen that it is not exact, so then you are unable to find the value of the phi. So that's over. What is the integration of this? It's a 2t square 2 over 3 is a 4 t raised power 4 is a t raised 3 over 5 is a 11, it is my 12. Fine. So it is 1 over 4. The first part is my 10 or 9, 19 over 15 plus 1 over 4. 60 is the LCM. So 9 for the 36. 76 plus 15. So 91 over 60 is the right answer of this problem. the value of the integral from the line segment 1, 1, 0 to 2, 3, 2. Clearly say it is my not closed. Once it is not a closed, you can never apply the Green theorem. But clearly say, can you find the value of the phi? Yes, you can see the first part I can written as a x, y, z. For the second part, I can written as a x, y, z. Third part, I can written as a x, y, z. Fine. Or instead of this, the complete component, I can written this part is x, y, z. Because if you open them, derivative with respect to x is a dx, yz plus and so on. So your phi will be, what is your phi? Derivative and integration cancel. So phi is my. Then your final answer is value of the phi at the point 232, the value of the phi at the point 100. This value is 0. So it is my 12 is the right answer of this problem. Make sure, student, if you are trying to find the curl of the f, and then you can apply this Stokes theorem. If you find the curl of the f, you will get the 0 answer. Fine, because you are able to find the phi. If you are able to find the phi, definitely the curl of the f is 0. Then your answer is 0. But Stokes theorem, can you apply the Stokes theorem? No, because the curve is not closed. If you apply the Stokes theorem, your answer will be 0, and that's the wrong answer. So the right answer of this problem is 12. In my gate examination video, where you can see this is the gate video, you can see it's a green and Stokes theorem. Fine. In this lecture, I think I mistakenly solved this problem and taken answer as a 0. So you kindly correct the answer. The answer is my 12 based on this concept. You can never apply the Stokes theorem because the curve is not closed. You can also watch these lectures, Green and the Stokes theorem, for finding the various questions as well as the exact differential equation for more detail about the concept. Okay, look at this another one. Again, the line integral. We can firstly draw the figure. It's a 0, 0. It's a 2, 2, 0, 2. Fine. This is the portion which is my closed. It's a polynomial. It's a trigonometric function. So both are continuous. Derivatives are continuous. Yes, you can apply the Green's theorem. Fine. Now what is the answer of this is? Double integration partial derivative with respect to x minus partial derivative with respect to y, 0, dx, dy. Oh, one more thing. If it is moving in the anti-clockwise direction, then this integration is my positive. If they are moving in the clockwise direction, then this integration is my negative. For all those, in all those previous examples as well. Fine. So it is already written that counterclockwise. Counterclockwise means they are moving in this manner. That is a positive. Fine. So this integration is my 6y. I can written as a dy dx. Fine. Now can you take the limits? Firstly, with respect to y, the value of the equation of this will be y is equal to x. So integration is x to 2. This value is my y is equal to 2. The limits of the x is 0. The value of this is my 2, 2. Fine. Now can you integrate them? 6 is outside. Integration of the y is y square by 2 from 2 to x. So it's a 4 by 2 is a 2 minus x square divided by 2 into dx. Now can you integrate them? It is 6 is outside. 2x x cube divided by 6. So it will be 4 minus 8 by 6, 0 will be 0. So that is 4, 3, 12 minus 4. 12 minus 4 is 8 over 3. So a to 16 is my correct answer of this problem. Look at this another one. Curve is my circle, which is my closed. Fine. This is my continuous. This is my continuous. So yes, you can apply the Green theorem. Partial derivative with respect to x, 7. partial derivative with respect to y, 3 into dx dy. 4 is outside, dx, that is the area under the curve. So this is the area of the circle. What is the area of the circle? Pi r square. Fine. So 9436 into pi is my right answer, and divided by pi also. If you divide it by pi, right answer is 36 is my correct answer of this problem. Fine. You can see that it's a very simple concept behind this line integral. Dear student, don't forget to like, subscribe and comment on the video. Again, you can see it's a line integral. It's a polynomial. So first condition satisfied. Circle of radius 2. Center at origin. Moving in the anti-clockwise. So yes, you can apply the Green theorem, because the curve is my closed and the functions are my continuous and their partial derivatives are also continuous. Double integration partial derivative with respect to x, 4y square. Partial derivative with respect to y, minus plus 4x square. Dx dy. So I can take 4 is outside. Double integration of x square plus y square dx dy. Because this is a circle, I can change into the polar coordinates. It is 4 times. It is my r square, r dr d theta. So limits are circle radius is my 2. It's a complete circle, so it's a 0 to 2 pi. So 4 is outside, 2 pi, r cube. It's a r4 divided by 4 from 0 to 2. Fine. So 4 will be cancelled out. It's a 16 and then finally 2 pi. Answer is 32 pi is my correct answer. And then you have to divide it by pi. So the right answer of this problem is 32 is the correct answer. Look at this another one. Boundary of the region 0, 0, 2, 0, 2, 2, 0, 2. That is my square. Can clearly say it's a closed. These are polynomials. Yes, and it's a counterclockwise. So they are moving in this direction. So yes, you can apply the Green theorem. Double integration. Partial derivative with respect to x minus partial derivative with respect to y, minus plus y. Dx dy. Fine. So you can take the limits. Limits are my 0 to 2, 0 to 2. So it will be firstly with respect to y. So I can write instead of the x, I can written as a dy dx. So firstly with respect to y is a y plus y square from 0 to 2 of dx. So it will be 4 plus 2 is a 6 of dx. So the right answer is 12 is my correct answer. And you can see how many seconds you are needed to get the right answer. It's a couple of seconds, maximum 10 seconds you are needed to get the answers. Okay, look at this another one. F is the region, unit vector, upper half of the circle. Upper half of the circle, only this part. Fine. Again, you can see that this is the closed curve. Yes, this is the closed curve. Fine. These are the polynomials. Yes, they are polynomials, so they are continuous. I can apply the Stokes theorem. Partial derivative of this function with respect to x, minus of 2x, minus partial derivative of this with respect to y, into dx dy. So I can take a minus as a common. It's a 1 plus 2x dx dy. I can change into the polar coordinate because it's a circle. So 1 plus 2 r cos theta into r dr d theta. What are the limits? Circle having the radius 1 and the angle is 0 to pi because of the semicircle. So if I firstly open this first bracket, it is r, is r square by 2. Integration from the r square by 2 is 1 over 2 plus, I can take a minus as a common, then it's again r square by 2, 2 will be cancelled, it is a 1 into cos theta. Fine, and clearly say the integration of this part will be 0 because it's a sine pi is 0, cos pi sine 0 is 0, and integration of this is my minus pi by 2 is the right answer of this problem. So you can see that it's a very simple again in a couple of seconds. Okay, let's see the curve of this cylinder in the plane z is equal to 2. Fine, is a counterclockwise direction. Now you can see it's a 3 dimension, so you have to apply the Stokes theorems. Clearly say these are my polynomials, exponential, trigonometry, all are my continuous. Can you find the curl of the f? I, j, k. Partial derivative with respect to x, y, z. So first part is my sin x plus e raised to power x, 4x e raised to power z cos square z. So firstly 0, 0. Second part is 0, 0. Third part is 4, 0. It is k cap. So the curl is my 4 k cap. So I can change into the curl of the f dot n cap of ds. So since it is a k cap, so your unit vector is also, so it will be my double integration of 4, ds will be my dx dy. Now dx into dy is my circle. So what is the area of the circle? Pi r square. R square is my, so the answer is 4 into 4, 16 pi. And your target is to find the value of alpha. Alpha is my 16 is the right answer of the problem. Okay, look at this another one. C is the boundary of the region. So firstly you can draw the graph. Check whether it's a closed and bounded. Closed, y is equal to x plus 2 and x is equal to 0. So which one is the portion? Fine, this is the portion, and clearly say this is my closed, and these are my polynomials. So yes, you can apply the Greens theorem. So that means the double integration, derivative with respect to x, derivative with respect to y, x minus 2y into dx dy. Fine. So I can take on minus as a common. It will be 3x square plus x minus 2y dx dy. So what are the limits? Firstly, with respect to x, I can take it on the horizontal axis. It is my 0. What is the value of the x here is root y, or the better is I can take on dy into dx. So I can take on the vertical step. This is my x square. Otherwise, you have to take on as a under root of y. And this is x plus 2. Fine. The value of the x is 0. What are the coordinates of this? This is the y is equal to x square. And this is x plus 2. I can find the equation. Minus 2, 0. So x will be my 2 and minus 1. This is my 2. Fine. So now you can solve this integration. I think that's very simple. You can try to solve it and let me know the answer in the comment box. What will be the answer of this problem? And see how many steps you are needed to get your answers. Let me know the answer in the comment box. Okay, look at this another one. L. What is the L? L is the curve which are defined here, which is e raised to power t, and y is my e raised to power t cos of t. L is a curve defined like this manner. So what does the meaning of this? This is the equation of the circle with the radius e raised to power t, and clearly say which is the closed polynomials. So yes, you can apply the Green theorem. Fine. Partial derivative with respect to x, partial derivative with respect to y, Now you can see this is a 0. Fine. Once this is a 0, what does the meaning of that? That means curl of the f is 0. Fine. So that means the Green theorem is not applicable. Whenever this integration part is my 0, that means the curl is 0. So curl is 0 means the Green theorem is not applicable. Once the Green theorem is not applicable, your target is to find the value of phi. Fine. How you can do that? I can firstly write f dot dr. Fine. I can take this is my x. So it will be my 3 plus 2xy into dx plus x square minus 3y square into dy. I can make them as a pair. This is xy pair. Fine. So how you can write this part is x square minus 3y square. So how you can write this pair? First of all, this is my 3 times of the dx plus, how you can write this part? I can make them 2 pair common, 2xy dx plus x square dy, this is the pair of the xy, minus 3y square of dy. Fine. Now you can see I can written as this is my 3x. How you can write this pair? Yes, you can write this pair is x square y. How you can write this pair is minus y cube. So what is your phi? Your phi will be 3x plus x square y minus y cube. Fine. Now you can substitute the value. So final answer is value of the phi at the point pi, value of the phi at the point 0. So what is a phi? At the value of the pi, x is 0. So this value is nothing but my 0. X is 0. Cos pi is my minus 1. And e raised to power pi into minus 1. Minus 0 means when t is equal to 0, sine 0 is 0, cos 0 is 1. So it is my 0, comma 1. So you can substitute the value. X is 0. So this value 0, this value 0. This value is my e raised to power minus e raised to power 3 pi. 0, 0, minus, minus, plus 1. So the right answer is e raised to power 3 pi plus 1 is my correct answer. Okay, look at this another one. Again, this is vertices. What is the meaning of that? This equation is x plus y plus z is 1. Okay, it's a 3D. It's a continuous. Can you find the curl of the f? I, j, k. We will see whether it's a 0 or not. So zx, xy, yz. So it is my z minus 0. So it's a z I cap. 0 minus minus plus x j cap, and similarly for here is y k cap. Fine. Then I can apply the Stokes theorem. But what is the n cap? It's the unit vector. So how you can find the unit vector corresponding to this case is I can write the coefficient. This is I plus j plus k. Fine. Because I can write x plus y plus z minus 1. I can write the partial derivative of this part is, which is my 1. So it's a 1 I cap. Similarly, partial derivative with respect to y is a j divided by, because it's a unit vector, so I can divide it by the magnitude. Fine. Then how you can find, because remember your target is to find the curl of the f and of the ds. Fine. And then how you can find the ds? ds will be, if you take dx into dy, then it will be n cap into k cap, or if you take dx into dz, then it will be n cap into j cap, or if you take dy over dz, then it will be my n cap into I cap. Choice is on your side. Fine, you can choose any one of them. So let's say I can choose the first part. Then what will be n cap into k cap? N cap into k cap is 1 by root 3. Fine. Now I can substitute all these values in the given equation, in the given formula. Curl of this, what is the dot product of this? Z plus x plus y divided by root 3 into dx dy over 1 by root 3. This will be cancelled. Fine. Now I can substitute the value of the x plus y plus z is 1. It's a double integration of this. How you can transform this into the xy plane? This xy plane will be my x plus y is 1. So the x plus y is my 1 is here, which is the right triangle. Half base into height is the correct answer of this problem. Fine. Remember student, in this case you are unable to get the value of the n cap directly. Fine. So in that case, the boundary are given to you. We can generate the unit vector from this. I can take the surface ds projection on the xy plane. So what is the projection of the x plus y plus z? Is this a plane? What is the projection of the xy plane? Projection of this plane on the xy plane, that is x plus y is equal to 1. Again, this is a similar one. You can see it's a GATE 2007 and it's a IIT JAM 2017. That's why it's very important to solve the PY question. Firstly, x plus y plus z is 1. Fine. Again, I can apply the Stokes theorem. So firstly, you can apply the curl of the f. So del y and z, k, j and I. So the value is my minus 2y, 3x minus 4y square, z square plus 3y. So it's a y, that will be 3, 0, 0, 0. K cap with respect to x 3 and minus minus plus 2 of k cap. So your curl is 3i cap plus 5 k cap. Then you can find the n, because your target is to find by using the Stokes theorem. How you can find the n? Again, from this case, I can find the value of the n cap is ijk divided by the unit vector root 3. How you can take the ds? Because it's a I and k. Fine. You can see that it's a I and k. So you can take I and k. So I can take, this is my dx dz over n into j cap. So that will be dx dz divided by 1 by root 3. Now you can multiply them. Double integration, curl into this. So it's a 5, 8 divided by root 3 into dx dz over 1 by root 3, which is again 8 times dx into dz. So what is the projection of this on the xz plane? X plus z is 1. So can you draw the diagram of the x plus z? This is the value of the x plus z, which is the area under the curve. So half base into height. What is the area of this triangle? So that is, the answer is 4 is my correct answer of this problem. Okay, look at this another one. F given to be this. Curl is my 0, f scalar vector. Okay, firstly you can find the divergence. What is the divergence? 2 with respect to y, 2 with respect to z, 2, which is my 8, non-zero. Fine. You can find the curl. Definitely, if you take the curl is 2x plus 3yz, this is my 3xz plus 2y and 3xy plus 2z. Fine. Can you find the partial derivatives quickly? So this is my 3x minus 3x, 0i cap. With respect to x, 3y minus 3y, 0j cap. 3z, 3z, 0k cap. That is my 0. So curl is my 0. And clearly say, if the curl of the f is 0, then you can write the f is my scalar function of this. Fine. So if the curl of the f is 0, then the curve is independent of the path, so it is 0 over the simple closed curve. Remember, the closed must be there. Is a closed, is a continuous, that's why it's a 0. How you can find the phi? Again, it's very simple. So you can make the pair. It's a x. I can write a 2x dx x. This is the yz. So I can take the pair of the y and z. This is the xy also. So I can take on the xy into dz. Fine. So can you find the pair of the xyz quickly? Otherwise, there is no need. Why there is no need? Because we obtained that the curl of the f is 0. Then definitely we can find the function f, which is the gradient of the scalar function phi. So the gradient of the scalar function, if you take del dot f, it is my del square phi. Del square phi is my Euler function, that is my this case. So definitely it is my correct options. So the right answer of the problems are A, B and C are my correct answer of this problem. Otherwise, you can also find the value of the phi in a very simple manner. That I think you can do it by own. There is not a big deal. You can make the pair, this xz. You can make the pair of the xz. Fine, and so on. Okay, this is a 3 dimension. So you can apply the Stokes theorem. I think that's a similar one. Fine. Quickly, you can write this part is double integration curl of the f n cap into ds. What is your n cap? From this case is I plus j plus k divided by root 3. And what is your ds is? I can map on the xy plane dx dy n cap dot k cap. So which will be my root 3 dx into dy. So now the only thing is you need to find the curl. So it will be my 2y x square xy. Fine. So can you find it quickly? K, J and I. X square xy. So it is a x minus 0. So it's a x of I cap. With respect to j is y 0. So it's a minus y of j cap. And from the case 2x minus 2. 2x minus 2 of k cap. So if you substitute this absolute value, dot product of this x minus y plus 2x minus 2 divided by root 3 into root 3 dx dy. Fine. So this is a double integration of 3x minus y minus of 2 dx into dy. Now rest, because it's a circle, you can convert into polar coordinates and get your answers quickly. So 3r cos theta minus r sin theta minus of 2 dx dy over the curve 0 to 1, 0 to 2 pi. This integration will be 0 when you integrate with respect to theta. This integration will be, this is a 0. Fine. Now you can solve this integration and see what will be your answer of this problem. I think that you can easily do it by own. And let me know again in the comment box what will be the answer of this problem. Remember, whatever the answer you have obtained, you have to take on the modulus value. Okay, look at this another one. Let C is the unit circle trans in the counterclockwise, then the value of P dx Q dy. P dx Q dy. First of all, P dx y dx minus x dy over x square plus y square. First of all, it's a closed. Fine. Is the partial derivatives of P and Q are continuous? They are not continuous. Fine. So once they are not continuous, can you apply the Green's theorem? You can never apply the Green theorem. So that means your target is to find the value of phi. Fine. So clearly say, can I write this function is derivative tan inverse x over y. Fine, because this is a derivative of the x over y. So your phi will be tan inverse x over y. Fine, or I can change into the circle. So x is my r cos, y is my r sine. So this portion will be my tan inverse cot of theta. So that cot I can replace it as pi by 2 minus theta. Fine, because I can write this number is, that number is pi by 2 minus tan theta. So this answer. Fine. Now over the unit circle you can substitute the value. So what is the right answer of this? Over the unit circle, that is my phi. So your answer is phi of 2 pi minus phi of 0. That is my phi. So that will be my pi over 2 minus of 2 pi and pi over 2 minus 0. So the answer will be minus 2 pi is the, and pi will be cancelled out. The answer is minus of 2 is the correct answer. Okay, look at this another one. What is this case? These are my ellipse. Fine. And you can see these are my closed. Fine. These are closed, but the partial derivatives of the f are not continuous. So that means you can never apply the Green's theorem. So that means your target is to find the value of phi. Again, I can write this is y dx minus x dy divided by x square plus y square. I can write this function is tan inverse x over y. Fine. So that will be phi is my tan inverse x over y. Is it okay? Now your target is to find the value of this over the curve. Now what will be the answer of this? So x over y, how you can find is clockwise and anti-clockwise. Okay. Also, you may heard about the concept of the winding number. That is also the same way. Fine. Now you can see the first part is integration with respect to this ellipse. Second is with respect to this ellipse. And you can see this is a complete circle 2 pi. But here is a negative. You can see for the first case, A is my 8. So the first ellipse my is this case. Fine. Going from the positive. So this is my positive. While for the second case, this is my negative. You can see the value of the B is my negative. That means they are moving from this side to this. Fine. So that means this is my clockwise. So the value of this is my negative. Value of this is my positive. And now it is of the complete circle. So the value of this integration, value of the first integration is my complete 2 pi. So the answer is 3 into 2 pi. Again for the second case, because it's a clockwise, it's a minus of 2 pi. So the answer of this problem is, you can see 2 pi will be cancelled out. 4 plus 3, 7 is my correct answer of this problem. You can also see these lectures, Green and Stokes theorem, for the complete details part. Okay, look at this another one, which is again a circle, which is my closed one, but they are not continuous. So the Stokes theorem is not applicable. So that means we can find the derivative of this part. So how you can find the derivative, which function is here? Again, you may solve like this manner. Fine. But clearly say, if I write this is x j means dy, x y of dx divided by b square x square plus a square y square. Look at that. If I taken the function as a tan inverse of y over x over bx, so what will be the derivative of this? Is this function is the derivative of this? So I can say it's a 1 over a square y square over b square x square into derivative of this part. So a over b I can taken as outside, it's a x dy minus y dx over x square. Now if you take the LCM, one x square will be cancelled out, so it's a b over b square x square plus a square y square into a x dy minus y dx. Now if you compare them, these are the similar term. So if I multiply this quantity by AB and divided by AB, then this integration will be my tan inverse AY over BX 1 over AB. Fine. So that means your phi is 1 over AB tan inverse AY over BX. Fine. Now over the complete circle, your target is to find the value of the phi at 2 pi minus phi at 0. Fine. So what's the value of this? Is it first of all divided by AB. The only case which is divided by AB is my A. Otherwise, it's a complete circle. So that is my 2 pi over AB minus 0 is the right answer of this problem. Because it's a binding number, so you can say this integration is my complete. This is my complete, so this part is my 2 pi. Because you can see that it's a 2 pi, that means over the circle. So that means first case is x is 0. When x is 0, it is a pi by 2. Fine. And but because of the complete circle, it's a pi by 2 plus pi by 2 and so on. Okay, look at this another one. Your target is to find, this is not the line integral directly, but it is look like say line integral. First you can draw the curve x square plus y square, y is equal to root 3 by 2, y is equal to root 3. This is x by root 3, this is root 3x. Fine. Now again it's a circle, so I can change this integration to be the polar curve. X is my r square cos square, r dr, radius is my 0 to 1. What is the angle? Can you find this angle? It is 30 degree. It is my 60 degree. Why? Because if you compare them, the slope y is equal to mx and m is my tan of theta. So the angle is pi by 6 to pi by 3. Now you can solve it easily. It's a 200 over pi. It's a r cube. Integration of the r cube is r4 divided by 4 from 0 to 1 of the cos square. So that will be 1 by 4, 50 divided by pi from pi by 3 to pi by 6. What is the integration of the cos square? I can write as 1 plus cos 2 theta over 2. Fine. So the integration of this will be 50 over pi. Half will be out. So it is theta plus sine over 2. Now you can substitute the value 25 over pi. It's a first of all pi over 3 minus pi over 6 plus when you substitute pi over 3, it's a 2 pi over 3, and if you substitute pi over 6, it's a sine of 2 pi over 3 over 2. So that will be cancelled out. It's a 6 is LCM, 3 minus 1 2, 2 pi by 6 into 25 by pi. So it's a 2. So that will be the right answer of this problem. So this is the way you can solve in a very simple manner problems. We will see the next lecture on the Stokes theorems and the triple integration. Till then you can watch this Stokes theorem so that you can get an idea how you can solve the problem quick manner. Also you can see the lectures on the IIT JAM solutions for the more details solution. I hope you can like, share and comment on the video. Best of luck students, and don't forget to subscribe my YouTube channel. Happy learning always.